All right, here's 4-7. Our schedule says a couple days, but as far as these notes, we'll do it all in one lesson. We can do them together. There's not a whole lot of stuff. Not a whole lot of stuff to cover. Really doing some simplifying and evaluating expressions using an inverse for the most part. Inverses can be helpful for solving, but we'll wait till section 8. We'll get there. We'll get to some of that, just not right now. Actually, most of it, I think, we end up covering in chapter 5. So somewhere down the road, we'll get to solving, just not yet. So let's start with this. A really simple expression, because I want to, start with something that we're ideally familiar with. You may want to have your unit circle available during this lesson, by the way. I'll refer to it quite a bit. That's coming off the unit circle. Something that you're hopefully familiar with. The sine value of 45 degrees is square root 2 over 2. In fact, as we've studied trigonometry, that might have been one of the very first things that we covered was, the sine and cosine values of a 45-degree angle. Well, now here's the deal. That is what we have called a trig function. Let's kind of break down its parts. You put in an angle, and I know most of the time we work in radians, but for this one I'm going to use degrees, because we like degrees too. Think of functions, right? Number in, number out, right? Input, output. You put a number in, you get a number back. With a trig function, you got to put in an angle, and you get a trig value back. The same thing happens as we always see with an inverse, is your x and y variables switch. So if we looked at one basic example with inverse sine, you would see in terms of like your x value, or the number you're putting in, now that's going to be a trig value, and an angle, whether you choose to do it in degrees or radians, it's going to be like your answer or your y value. Okay? That's like the big fundamental difference that you see with an inverse trig function. All right? If you were to go to a calculator, which we'll use some in class, I'm not going to talk you through any calculator stuff here, but if you were on your calculator to do an inverse trig function and then you plug in an angle measurement, it's pretty likely you're going to get an error message from the calculator, and it's not going to be happy with you because what you're asking it to do isn't possible. If you say an inverse trig function, it's expecting a trig value. Now let's talk through some of the basics here. Okay. There's a lot of restrictions with inverse trig functions, and in fact, I can give you one example that we just did. Okay, so inverse sine of square root 2, actually let's go back up to that, of square root 2 over 2 is 45 degrees. Okay, now if you're going off of your unit circle, you might have found yourself saying, wait a minute, what about 135? What's wrong with that one? Now, we want these inverse expressions to be functions, which mean we can only get one answer, okay? So I'm going to reluctantly cross out 135. For the inverse sine function, we would take the answer of 45. There's nothing wrong with 135, it's just that there are lots of angles. Like when you think of coterminals, like if we were to go and add or subtract 360, there's lots and lots of other angles that have that sine value. We kind of want to be set up to use coterminals to get all the others. So what we're going to get from our inverse expression is kind of the one that we want to start with, okay? And that's why down here you see all these restrictions. One other thing with notation, if you see in arc sign, that's the same thing as inverse sign. Don't be fooled by that. Okay? So check this out. The range down here from negative pi over 2 to pi over 2, we're now back in the units of radians. Here's essentially what's going on. If you want to go around the unit circle and you want to cover every possible sign value, look at quadrants 1 and 4. As soon as you move over to 2 and 3, you're going to get repeats. Okay? So basically what's happening here is this inverse sine function just covers quadrants 1 and 4. Think of like this part over here is quadrant number 1, and this part over here is quadrant number 4. Okay? But that goes all the way from negative 1 to 1, so we've got all the possible sign values that we would want to plug in. Inverse cosine looks similar, except a little different. Notice it's got the same domain. The difference here is if you want to cover all of your cosine values, you'll get them in quadrants 1 and 2. Okay? It's the same idea. Cosine just works a little bit different. Notice with the domain here with inverse tangent, it doesn't have any restrictions, okay? Tangent is a different ratio from sine and cosine, so that part is really different. It has some similarities to sine, that if you want to cover all of your tangent values, look to quadrant 1, and then look to quadrant 4. Alright, so let's do some evaluating. This is a part where you would definitely want to have your unit circle, okay? So here's the big thing we need to talk through with these is, okay, so our answer is going to come from quadrant 1 or 4. This is inverse sine. It's going to be 1 or 4. Remember, everything in quadrant 1 is always positive, so I see a negative sign value, so I should immediately think, as far as my unit circle, I'm looking to quadrant number 4. All right? Now, the most common answer that comes up when we look is 11 pi over 6, which it isn't. Okay? Now what's going on here with inverse sine is that our answer, like we saw on the other slide, has to be from negative pi over 2 to pi over 2. Okay? Now don't get me wrong, 11 pi over 6 has a sign value of negative 1/2. Okay? But again, from the inverse function, we kind of want the best one to start with. We can use coterminals to get all the others. So if you're down in quadrant 4, just think of it in terms of a negative angle. What we actually want for our answer here is a negative pi over 6. Okay? And for the rest of the chapter, exactly why that's the first answer we want is probably going to be a little bit incomplete. We'll really complete that discussion in chapter 5. When we start to solve trig equations, you'll see the full picture of why that's the one that we want to start. Now number 2, notice it's positive. Life is good. We're off in quadrant 1, right? It's sine, so it could be 1 or 4. There, it's just going to be the angle that I see. Pi over 3 is the one that we want. Again, you add or subtract 2 pi, you're going to get a bunch of other angles that have that same sine value. Let's move on to cosine. Okay, now a little bit of an adjustment happens here with cosine. I'm not looking to 1 and 4 because the answer that I want has to come on the interval of 0 to pi. This cosine value is positive, so we're in quadrant number 1. We'll take pi over 4. Inverse cosine of negative 1. It's a negative cosine value, so we're done in quadrant 1. Look over to 2, and it will actually take you all the way over to pi, which is like the upper end of the interval that we'll take our answers from. But that one will do it. That's the one that we want. If you're looking ahead to example 6, little interesting scenario there. Number 1, I already put the answer. I don't know why, but it's already there. And I put it in degrees, which we haven't been doing. So the thing I have going for me on that final answer is it's actually correct, so good for me. But we'll get to that one in a minute. All right, arctangent. Back to quadrants 1 and 4. And remember, quadrant 4 is a little bit funky that we're going to give it as a negative angle if that's where our answer is. Okay, tangent is y over x, so what we're really looking for is on the interval of quadrant 1 down to 4, where is our y coordinate 0? It's right at 0, okay, where the coordinates are 1, 0. It's negative. Head down to quadrant 4, okay. What you would, this is one of those goofy cases where a lot of you, what you would put, if I'm going back to radians, is you would put 7 pi over 4, okay. Again, I'm not disputing that angle has a tangent value of -1. It's just with the inverse, it's not the one we're looking for. Okay, in some ways, it actually is. I just don't want to call it -7 pi over 4. We want to call it negative pi over 4. That's the one we want to start. Okay? All right, a composition of inverse functions, which basically means we have an expression that has a trig function and an inverse. It's got both. Comes up in solving. All right? And now what I'm going to do here is a slick little trick that you can use an inverse for. It's going to be kind of cool. Because basically what's going to happen is I've got this pile of stuff. I think the book gives a couple of examples about these cone-shaped piles of salt, corn. They're kind of all agriculture-based or mining-based. But basically what it says is the shape of the cone and this angle down here, it varies. It depends on what you're stacking. Like different types of foods or crops or rocks or whatever, they form a slightly different shape depending on what exactly it is. Okay, I think this one I took here was from a pile of salt. Okay. So here's what we know, that it was 11 feet tall, and it had a radius at its base of 20 feet. Okay? Now I'm going to get an expression set up here that the tangent of our angle is opposite over adjacent. That's why I chose the tangent ratio. Its tangent value is 11 over 20. Right? Easy enough. Now, I could solve that using an inverse trig function and say tan inverse of 11 over 20 is the angle. Okay? Except, I don't want the angle. I mean, I could get it, and that would be, you know, that would be just fine, except what I'm saying here is we added more salt to our pile, and the radius of the base is actually now 30 feet, not 20. How tall is the height? Okay? Now, one way to do this, and if I just kind of set you off on your own to solve it, my guess is you would use a calculator with an inverse trig function to get a decimal approximation, which with a composition of an inverse function, we actually don't need to. I could head down here and say, all right, this whole new, it's kind of like new scenario here, tangent of our angle, which is not going to, even if we add to the pile, the angle is not going to change, is now going to be our height over 30. Okay? Now this is a little bit of an issue because this equation has two variables, except I have a different expression for the angle, and I could type in, or write in here, inverse tangent of 11 over 20 equals h over 30. Okay? Now, you might guess in this case that the tangent function and the inverse cancel, and they do. That's not always going to happen. It does most of the time. But then we have the problem set up like this, and the math actually gets easier. I could cross multiply and divide. It would just basically be 11 times 30 over 20, which would be 16.5 feet. Okay, no decimal approximations. Really, I mean, honestly, if you could crunch those numbers at the end, very possible could solve that problem without needing a calculator at all, just by using an inverse tangent function. All right, so the rest of the way here I've got just simplifying some expressions that have a composition. All right, and a lot of the times you're going to get something like this, like we just saw, right, where they cancel, boom, -5. Okay? Not always going to happen, right? Not always going to happen. Like this, the next two, that's not the way it's going to work out. Like the answer for number 2 is not 5 pi over 3, and the answer for number 3 isn't pi. Okay? Now let's say we do. Let's say we cancel these out, right? Maybe you'll take that approach and you'll say, oh, hey, 5 pi over 3, good for us. Awesome. Well, we did an inverse out here, which means after we do an inverse, remember, we got to be picky that we get the one answer that we want. 5 pi over 3 is too big. Okay? It's too big. It's over pi over 2. Okay? So basically what you could do at this point is go back to your unit circle and check that you're where you belong. Like, first of all, check that you're in quadrant 1 or 4. Okay? Now when I check 5 pi over 3, I see, oh, good, I'm in quadrant 4, I'm in the right place, but I shouldn't call this 5 pi over 3. Again, if we're down in quadrant 4, we're going the negative route. Let's just call that negative pi over 3. Same spot, same sign value, okay? But again, when we're taking this inverse out here, we're going to be picky that we get the one and kind of the first answer from the inverse that we want. The second one is a little bit different because the inverse is now on the inside. You would probably catch this with a calculator because it's not going to be happy with you because you're taking the inverse cosine of a number that's over 3, but cosine values can only be at most 1. So you're going to get a nice error message. So here's a case where it's tempting to just say they cancel out, but it's going to be undefined. Okay? Now notice the big difference here. On number 2, the inverse was on the outside. So there I was good to cancel. I just had to check and make sure I got the right answer. If you're doing the inverse on the inside and doing that first, make sure it's possible to do. Okay? That actually goes back to the tangent example I did here. Inverse tangent of -5 is fine, right? Inverse tangent, like a tangent value can be -5, so I didn't need to worry about that. Sine and cosine are restricted, and they can't be outside -1 to 1. All right, let's hop down here, right? Evaluating a composition again. Except now, notice there's not going to be like a canceling action going on because the two trig functions aren't the same. You know, both have an inverse on the inside, but on the outside it's a different trig function. For these, diagram. Okay? It's just a description of what's going on with this angle. Okay? We have inverse cosine on the inside, which tells me this problem is either in quadrant number 1 or it's in 2. It's positive, so I know it's in 1. So I start to mark my angle. I know the adjacent side is 2, the hypotenuse is 3. Little Pythagorean theorem tells me that, and that would come from that's really the y value that was missing, right? And as always, because this problem is asking you for a tangent value, like it wants a trig value as an answer. But what it's basically describing is you've got an angle in quadrant 1 and its cosine value is 2/3. What's that angle's tangent value? Well, whenever you have that diagram set up, you're always going to have all 6 trig functions. So I definitely have the tangent going from, you know, my opposite side is the square root of 5, and my adjacent side is 2. Last one down here, but absolutely not a different approach. Okay, probably the trickiest part is right here. What quadrant are we in? It's inverse sine, so I narrow it down right off the bat, and I know we're in 1 or we're in 4. It's negative, so I know we're in 4. If it had been a positive sine value, then I would have said that we're in 1. Y is -3, R is 5. That's a real basic Pythagorean theorem because they stay with whole numbers the whole way. And it's 4. Cosine would be adjacent over hypotenuse, or 4 over 5. Okay? So basically, if the two trig functions, if you have a composition, if it's the same trig function, you can probably cancel them out, but just double check that that isn't undefined and that you've got the right angle. If it's two different trig functions, set up a diagram.